Hello, my name is Gizzi, and today I will briefly discuss my work in action discovery through behavior babbling. The motivation of this work exists within the context of creative problem solving, where an agent which acts and plans at a symbolic level is first able to accomplish a goal. In the case that the agent later encounters novelty in its environment, it is no longer able to successfully execute the same action sequence. In this case, the agent must update its symbolic knowledge base in order to accurately reflect its world. Here we show an overall framework for how an agent could perform this sort of updating, namely through cycles of action discovery and replanning, until it finds an action which facilitates or directly accomplishes its desired goal. This action discovery takes place through behavior babbling described next. The first stage of action discovery is a passive incubation stage. Here the agent generates a list of candidate actions to vary by sampling from the first portion of the original action sequence all the way up until the failure action. The sampling is weighted more heavily toward those actions which occurred closest to the failure action. The agent is able to utilize two modes of candidate generation. In focus mode, the agent samples solely from the failure sequence, varying only the parameters of those actions. In defocus mode, the agent also samples from the failure actions, but instead loosens its constraints to allow for other arguments for those actions. As you can see, each candidate has an assigned focus parameter value. The second stage of action discovery is an active incubation stage. Here, the agent executes the elements in its candidate list, varying the selected focus parameter. The parameter is varied by partitioning it evenly from its lower to upper bound values with a chosen interval partition value. This value is a chosen experimental parameter. Actions executed may be added to the knowledge base using the following two criterion, where in focus mode adds actions that accomplish the same effects as the original action. In defocus mode adds actions which accomplish effects novel to its original action. We tested our framework in three scenarios of varying complexity levels. The first is a simple scenario. The second is a scenario which tests focus mode, and the last which tests defocus mode. We executed tests to evaluate overall performance and found that the interval partition value selection affects overall execution time more drastically in complex scenarios than in the simple scenarios, which was expected. We were surprised at the diversity of success actions discovered by the agent, shown in figure 2. Many of the actions listed had not been initially assumed to render success. Future work should consider using alternative methods like reinforcement learning for learning low-level action controllers. Thank you very much, and I'd be happy to take questions offline.